electric energy and power. So let's say let's consider a conductor. Okay, there is this resistance. This point is A, this point is B. Current is going from A to B. That means potential at A is higher than potential at B, because current flows from higher potential to lower potential, right? And here the potential difference is, let's say, VA minus VB, which is greater than 0. That means VA is at higher potential than B, right? So amount of charge that transfers from A to B is given by what? Delta Q. We can write it as I into delta T. Let's say it takes delta T time for charge to go from A to B, right? Now let's talk about potential energy. So potential energy at U can be written as delta Q into VA, right? Since we can write potential is given by work done per unit charge, okay? Or we can say energy by charge. So we can write energy as Q times V. By that way, we can write potential energy at A is delta Q into VA. So we can also write potential energy at B as delta Q into VB, right? So what is the change in potential energy? It is nothing but UB minus UA, right? Which can be given as delta Q times VB minus VA. It will be negative, right? Delta Q times V. Why? Because potential at B is lower than potential at A. Yes or no? Yes, of course. So if a charge move without collision, then kinetic energy of charges also change, right? So by applying conservation of total energy, changing kinetic energy plus change in potential energy should be 0. So from here we can write delta Q must be equal to minus delta U. But since here delta U is already negative, we can write potential energy as delta Q into V, or in another sense I into delta T into V. Why? Because delta Q is I into delta T, right? Which is of course greater than 0. But however, on average, charge carriers do not move with acceleration but drift velocity. Okay, charge carriers move with drift velocity due to collisions with ions and atoms during its transmission, right? We already discussed this in the drift velocity section. So the kinetic energy gained by charges is shared with the atoms during collision. As a result, atoms vibrate more rigorously, and this energy is dissipated as heat in conductor during time interval delta T. So we are interested in find out the heat dissipated would be what. So we know that delta W is given by IV into delta T, that we have just written, right? So the energy dissipated per unit time is the power dissipated. Power is nothing but work done per unit time, right? So power is given by delta W by delta T. Here delta W is IV delta T upon delta T, which will give us current into voltage. So power is given by VI. This is the most important expression in electricity, okay? And if we use here Ohm's law, which is V is equal to IR, our expression will become P is equal to I square R, or we can say V square by R. So this is the power dissipated, power loss, or we can say ohmic loss. Okay.